LG Energy Solution has developed a new, long-lasting all-solid-state battery that can be charged at room temperatures, moving a step closer to commercializing solid-state batteries, South Korean publication Pulse reports. Choi Mira reports in the Pulse, a South Korean publication, that the South Korea's leading lithium-ion battery maker announced Friday that engineers at the company and University of California San Diego jointly developed a new type of silicon all-solid-state battery that uses both a solid-state electrolyte and an all-silicon anode. The company said the researchers demonstrated a technology that can develop a battery that delivers 500 charge and discharge cycles with 80% capacity retention at room temperatures for the first time in the world. The new work is described in the Journal of Science. Silicon anodes can offer 10 times higher energy density than the graphite anodes mostly used in today's commercial lithium-ion batteries. But they degrade with liquid electrolytes, so the existing solid-state batteries have relied on metallic lithium as an anode, which restricts the batteries to be charged at 60 degrees Celsius or higher. In order to overcome the limitations, the researchers used microsilicon and eliminated the carbon and the binders. The team also replaced liquid electrolyte with a sulfide-based solid electrolyte, which is extremely stable in batteries with all-silicon anodes. In addition, the microsilicon is less processed and less expensive than the nanosilicon that is more often used. LG Energy Solution said the new work has brought them much closer to realizing all-solid-state battery techniques. LG Energy Solution is delighted that the latest research on battery technology with UC San Diego made it onto the Journal of Science, a meaningful acknowledgement, said Kim Myung-hwan, President and Chief Procurement Officer at LG Energy Solution. As a leading battery manufacturer, LG Energy Solution will continue its effort to foster state-of-the-art techniques in leading research of next-generation battery cells, he added. Enabling reliable, long-lasting energy storage for off-grid applications, lithium-ion battery technology has truly changed our world. Even with these advancements, however, there is potential to improve the lithium-ion battery. One advancement that could once again change the way we store energy is the development of the solid-state battery. Let's dive into this unique design and learn more. What is a solid-state battery? Before we learn what a solid-state battery is, we need to understand how current lithium-ion technology works. Lithium-ion batteries work by letting ionic lithium cross the electrolyte barrier between the battery's anode and cathode, the positive and negative ends. This electrolyte is a liquid in standard lithium-ion batteries. A solid-state battery uses a solid electrolyte to regulate the lithium ions instead of a liquid one. So the main difference between a lithium-ion battery and a solid-state battery lies within the electrolyte. While lithium-ion batteries, and most other batteries, use a liquid electrolyte, solid-state batteries use a solid electrolyte. Read on to find out what this matters and what it means for the battery user. How does a solid-state battery work? Every battery has two electrodes, an anode, negative side, and a cathode, positive side. These two electrodes are made of an electrically conductive material. Between these two electrodes, and within them, is an electrolyte containing electrically charged particles, ions. The electrolyte allows lithium ions to travel through it to combine with the anode or cathode, depending on charging or discharging. This chemical reaction permits the flow of electrical charge between the cathode and anode, through a circuit, allowing a battery to generate an electric current to power your device. So when any device is connected to a battery, let's say a light bulb, for example, a chemical reaction occurs between the anode, cathode, and electrolyte, creating a flow of electrical energy to power the light bulb. A lithium-ion battery uses a liquid electrolyte to regulate the flow of current, and a solid-state battery uses a solid electrolyte. And this is the difference that will matter. Here's how. Benefits of solid-state batteries, aka why you will want one. There are multiple benefits to solid-state battery technology. In short, the solid electrolyte used in a solid-state battery provides higher energy density, longer lifespan, and increased safety in a smaller size. Let's take a closer look at how this translates to how a user will benefit from solid-state battery technology. Smaller and more lightweight. Energy density measures the amount of energy a battery contains proportional to its weight. Solid-state batteries are said to be capable of delivering 2.5 times more energy density of current lithium-ion tech. This tremendous increase in solid-state batteries' energy density means that they will be far smaller and lighter. Higher energy density means that batteries could be much lighter and store the same amount of energy. Weight is a critical concern for mobile power applications, so this could be a game changer. Cars, trucks, RVs, boats, and airplanes all could benefit from being lighter. Electric vehicles also have much to gain from this technology, as they could get much more range with less weight and space in battery storage. Faster charging times. Solid-state batteries can work at very high rates of power. Research suggests that they may be able to recharge 4 to 6 times faster than current technologies safely. Safer battery experience. Liquid electrolytes found in lithium-ion batteries are extremely volatile and highly flammable. These electrolytes also mustn't be exposed to air. Solid-state batteries contain no liquid parts and will not have this volatile component. So while lithium-ion batteries are subject to events like thermal runaway leading to explosion and fire, the solid electrolytes used in solid-state batteries are non-flammable and thus present a lower risk of igniting a fire. While the battery may get hot, there is nothing flammable within it that will catch fire. The frosting on that cake is that these batteries will require fewer safety systems than lithium-ion batteries do. Eliminating additional electronics can contribute to smaller, lighter weight battery packages, which further enhances solid-state batteries' energy density. These batteries may not even require an external BMS in certain situations, greatly simplifying its construction. Much easier to manufacture. Working with a volatile liquid that cannot be exposed to air is a huge challenge that could be completely eliminated with solid-state battery technology. A solid electrolyte could enable much faster production that uses less material and energy. Are solid-state batteries too good to be true? Absolutely not. Research is being done around the world, with new publications and papers coming out regularly on advancements. With so much to gain from solid-state technology, there is significant interest in it from many research firms and companies. In conclusion, compared with conventional lithium-ion battery technology, solid-state batteries will be lighter, smaller, more powerful, charge faster, last longer, and be safer. Now you know what a solid-state battery is, what it can do, and why you want one. Thanks for watching, friends. Please, subscribe to our channel and like this video if you found this report helpful. Also, ring the bell please, so you don't miss my next coverage. God bless you everyone and peace be with you.